Okay, so expanding quadratics is actually really easy. There's a default way to do it, which is sometimes longer, but then there are special rules as well. So if we have a look at question 1a, 2x plus 6, x plus 5, right? I'm going to get some different colours here to show you what I'm doing. So I use something called FOIL. Now, it just means it's just a method, a process, if you will, of how to solve questions like this. What it means is you multiply the first two terms. So 2x times x, okay? Then you multiply the two outside terms. So plus 2x times 5. Then we're going to multiply the inside terms, which gets us plus 6 times x. And then finally we're going to multiply the last terms, which gets us plus 6 times 5. If you simplify all that down, 2x squared plus 10x plus 6x plus 30, 2x squared plus 16x plus 30. That's where you need to stop, right there. So that's FOIL, that's the default way of doing it. Sometimes you might see it done with arrows instead of what I just did there, so you go first, outside, inside, last. Okay, sometimes you'll see it done like that, but that's sort of the default way of expanding brackets if it doesn't fit, or expanding quadratics, if it doesn't fit one of the special rules I'm about to talk about. So there are 3 special rules that can help you shortcut expanding if you know them. The first one is perfect squares. Okay, so perfect squares. If you were given a question that looks like that, okay, so ax plus b all squared, that's a perfect square, okay, and that comes out at a squared x squared plus 2abx plus b squared. So you can just substitute things in. Now your book doesn't give you this with a negative in the middle of it, so I'm going to do that here. Ax minus b all squared is pretty much the same, only there's a minus right there. So that's your perfect squares rules. There's not much to do with it other than, I'll give you one example now, but it's just follow the rule basically. So first example in your book is question 2a, and it's 2x plus 3 all squared. So if we follow our rule, we go, okay, so we're using the top one here, so ax plus b, so a is 2, b is 3, so a squared is 2 squared, which is 4, x squared goes there, plus 2 times, so the 2 from there, times 2 is 4, times b, which is 3, so that's 12x, plus 3 squared, which is 9, and we're done. Okay, so that's perfect squares. It's just a matter of following whichever rule suits and then substituting things in. The next special case is, I call it dots all the time, but your book calls it dots. Alright, I call it dots. Your book also has DOS, okay, but it's difference of squares. Okay, and the T stands for perfect and the T stands for 2 squares. Alright, so just dots, dots, DOS, whichever one you want to remember it as, doesn't really matter, but that happens if you're given a question ax plus b and ax minus b. It's really simple to expand that out. All you do is a squared x squared minus b squared. Okay, so if you've got the same terms in both brackets and there's only a change of sign between them, you just expand it like this. So I'll run through one example of that. Again, the first question in your book that does that is question 3a. So we've got 2x minus 6 and 2x plus 6. So it doesn't matter which order they are in, you still follow this rule. So a is 2, b is 6, so we just go 2 squared, which is 4, x squared minus 6 squared, which is 36. Okay. The final sort of special case is if you have a number out the front of your brackets. So the example I will pull out of your book is question 4a, 2x plus 6 3x plus 5. So it doesn't fit dots, it doesn't fit perfect squares, okay, but it does fit that FOIL thing. So I'm just going to write FOIL here so that you've got that visual cue to remember what we're about to do. So we expand our brackets first, so we'll leave the 2 out. X times 3x plus x times 5 plus 6 times 3x plus 6 times 5. And then we simplify that, we'll keep our 2 out for now, so 3x squared plus 5x plus 18x plus 30. And now I'm going to do one more step before I deal with that too, 23x plus 30. So now all I'm going to do is I'm going to bring that 2 in and multiply each of the terms inside that final bracket. You can actually see what I'm looking at. Multiply all the terms inside that final bracket by 2. So to show you what I'm doing there, so it's 6x squared plus 23 times 2 is 46x plus 60, and that's our final answer there. So that's the expanding quadratic expressions. The next exercise we'll have a look at factorizing quadratic expressions, which uses the same rules going backwards, except for FOIL you can't use that going backwards, but there is a neat little trick that I use that may help you as well.